Morning, everybody. That's not too bad, but let's try it again. Morning, everybody.
Morning.
Yeah, there we go. Welcome to Windows Azure Infrastructure Services. My name is Mark Krasinovich. I'm an architect in Windows Azure. I was the architect for Infrastructure Services release, and this morning I'm going to share with you a tour through what we delivered GA on April 14th, which includes the virtual machine features as well as the virtual networking features that go with them. Before I start, I want to kind of get an idea for how much experience the room has with Windows Azure and also to set expectations around what I'm going to cover this morning. So first, how many people have deployed a virtual machine on Windows Azure? How many people have not? How many people do not know what a virtual machine is? No, I'm just kidding. So, okay, looks like we've got about half and half, which is good. So the demos for some of you might seem like familiar, and some of you it will be new. Let me ask you this. How many people are scared of PowerShell? I am. I admit it, I'm scared of PowerShell. Although Azure has forced me to learn PowerShell a little bit, so I'll be showing you PowerShell. This session is a level 200 session, but that doesn't mean that I'm going to talk marketing fluff. It just means that I don't expect you to come in with that much background on Windows Azure. So that's where the level sit is. If you're afraid of seeing PowerShell or if you're afraid of me opening Visual Studio, then this session is going to be too advanced for you. If you want to see me code, then this session is too limited for you because I will not be coding in Visual Studio. I'll just be showing you how to convert a project into a cloud project. So with that, why don't we get started? And I'll kick the session off right away by first just creating a brand new virtual machine in Windows Azure using the quick start create method, which is the one that somebody just approaching the platform for the first time when they see, hey, I can create virtual machines in Windows Azure, might go about doing it. So let me pull up IE. First, I wanted to actually stop here and show you the new Windows Azure look, which we deployed yesterday morning. It's really cool. Now, one thing that I noticed was here on the last button is Scott Guthrie. How many of you are familiar with Scott Guthrie? There's Scott. And that's an interesting expression I thought he has on his face there. So I went and asked the guy that took the picture, what the deal was with that. And here's what he said Scott was really saying. So if you know Scott Guthrie, then that joke will make sense to you. If you don't, then maybe not. But anyway, Scott, I told him I was going to show this to you guys, and he thought that was funny. And he said, yeah, that's really what I was saying. So first, before we get to this slide, let's go back to the portal and create a virtual machine. By the way, I've never seen a curved data center before. I don't think that's really ours. I'll try to find out where it is. It's like the Microsoft Death Star data center. So why don't we go and create the web? So here's the virtual machines node, and actually, every time I use the portal, I'm like, I want to create a virtual machine. So I click on this thing, but that's not the way you do it in the new modern interface. You come down here to the New button, and this gives you the ability to create new resources of any type, including the virtual machine resource, which is categorized as compute, virtual machine. Then you'll see that there's two options here, quick create and from gallery. I'm going to do quick create just to show you how easy it is. And there's just one set of edit boxes you got to fill in here, and then you can press create a virtual machine at the bottom. Question, DNS name. So what's a good DNS name we can pick for this thing? Anybody? Death Star. Watch it be taken. That shows up in green. Oh. Just Star 2013. Oh, the goo. The goo. Watch that be taken. I think we're good to go. It's thinking hard about the goo. All right, let's give it a username while we're waiting for that. And I'll call it Azure user. Oh, actually, you know what? Let's create a Linux one. Yeah, just show you we're equal opportunity cloud. And the username picked is Azure user. So I'm going to pick a password. I'm not going to ask you for the password because I don't trust you that much to not mess with my virtual machine. And then we can create it in any of these regions. So I'm going to just let it create in the default region. And assuming that the network picked that up, my button click, we should be on our way to creating a virtual machine. Yeah. Oh, I'm still checking the password. So there is a password complexity, just to know why it's taking so long. There is a set of password complexity rules we put in place, which is not just the standard Windows, you need to have upper, lower case, and those kinds of rules, but also we have a list of passwords that people like to use, that hackers know people like to use, and we stop you from using them in the public cloud because we have seen hackers go RDP trolling and SSH trolling through the network, through the internet. And so if they come across these machines in Azure, then they will crack right into your machines. And but it looks like we're having a network issue here, which I apologize for. Let me see if I can reset that. Now, a cloud talk without the cloud being accessible is a little problematic. And I hope I'm not forced to say, use your imagination. Okay, we'll come back to that. That doesn't count as the time that it takes to create a virtual machine. So let me talk now about how we got to where we are in Windows Azure. Because those of you that have followed Windows Azure from the beginning, and how many people have followed it back from 2007 or PDC-08, so some of you remember that Windows Azure started as, hey, we're platform as a service. It's the new way of looking at the world. Cloud design points, scale out, highly available services. And that's what the platform was designed for. But one of the issues that we ran into, especially as we went out public, not to mention just trying to get internal properties on Azure, is that developers wanted to bring their existing code onto the platform. And that existing code was, in many cases, incompatible with the platform as a service foundation that we'd created. For example, people wanted to bring native code. And originally, the platform was pure .NET, partial trust. So we had to make it full trust, allow the ability to bring native code in. Then we added things like startup tasks, because people wanted to have things run before their role actually got started. People wanted to install things that required administrative rights on the system. So we had to add admin mode. And you can see us adding these, what we call on-ramps of existing code up into the cloud over time. But the biggest on-ramp, of course, is one that lets you just bring standard server applications up into the cloud. And that's what infrastructure as a service is all about, giving those applications the virtual machine that they expect. That when the SQL server actually writes something to the SQL database, that data persists and is durable, so that if the machine crashes, if it reboots, if the virtual machine moves from one server to another, that data is going to be there. And so that's what we started on a journey about 2 years ago. We went into preview about a year ago, back in June of last year. And then in April of this year, we went into general availability with this set of features that I'm going to be talking about this morning. All right, let's see how that VM is still checking out that password. All right, so I don't know what is going on. What's that? Try a different location. That shouldn't matter for this because the portal's just checking rules. Let me see how this is doing in general. All right, yeah, the network is not good. Ooh. It's going to be a fantastic session at this rate. Yeah. Let's see how the portal is responding. What's this? Oh. Wait. All right. Now we can count that as the start of creating the virtual machine. And this should take about 3.5 minutes or so. So we measure the performance of our virtual machine deployments. And for Linux, it's about 3 minutes, 3.5 minutes to get it into a virtual machine that's ready to go. So we'll come back to that in a second. But let me go back to, and maybe I won't need to use this, I'll set it aside. This is a 4G, 3G access device. So, like I said, we started as platform as a service. Now we've got infrastructure as a service. What's the difference between those two? Well, one, in platform as a service, you write code that is tuned for the platform. And that means, for example, that you don't necessarily do things the same way that you would on a standard virtual machine. In our original platform as a service, for example, for you to discover the other virtual machines that were part of your cloud service or your application, you would use a runtime API that would say, give me the TCP/IP addresses of the other machines that are in my cloud service. Standard Windows Server applications don't call APIs like that. They use what to discover what the TCP/IP address is of other machines that it wants to talk to? DNS, right. They use DNS. So that's one difference, but here's some other big differences. For example, storage. This is the number one big difference between our PaaS and our IaaS, and that is the durability of the storage that's underneath the virtual machine. With a PaaS virtual machine, which is a worker or a web role, the virtual machine is running on a server in our cloud, and the disks that it sees, its C drive, its D drive, are both stored locally on that server. So if that server dies, if the power goes out on that server, or if the disks fail, that virtual machine's lost its data, any data that's stored there. It's going to get reincarnated on another server, but it starts its life with amnesia. It doesn't remember what it was doing on the other server because that's data is left behind. And that is a stateless application. If it wants to persist any durable storage, it writes it out to some external durable store like Windows Azure Storage or Windows Azure Database. With infrastructure as a service, though, these applications like SQL expect their local disks to be durable. And so that is the difference here, that there's persistent storage under these virtual machines. If that server that virtual machine is running on dies and that virtual machine moves to another server, it'll reboot, and for it just looks like a crash. But any data that it wrote is going to be accessible to it. So those SQL database is going to be there. Then you can see some other ones. Networking, I gave you one example. The way you discover topology is different. But there's also configuration of the connections between the virtual machines is done using a model in the PaaS world, whereas IaaS world, you just open firewall ports. And then you can see the primary use targeted at different things. Now, the benefit of PaaS, which I'll come back to at the end, is that you get, if you write to this programming model, it's very easy to scale out, very easy to get high availability. Whereas if you look at IaaS, it's very difficult and complex to make an application that you can just scale out quickly. It's also very difficult, even more difficult, to make an application that's truly highly available. Like SQL servers made big steps in high availability, but going and configuring SQL Server mirroring or SQL Server always on is a pretty intensive task, whereas doing a PaaS scale-out service that's highly available, very straightforward. When we started out on this journey 2 years ago, we said, well, Amazon's been in the market for a while, so we can just go chasing after Amazon, go after its list of features and say, let's do that, check, let's do that, check, let's do that, check. Instead, we decided to take a different approach, which is to make sure that the features we delivered were all cohesive whole so that you guys could do the things that you want to do in our cloud and not just run off a cliff when we were missing some feature because Amazon didn't have something exactly the same as what we were looking at or what we were trying to build. So these are the criteria that we set out for our goals. We wanted to make it an IT pro experience. And what IT pro experience means is that you don't need to have Visual Studio knowledge. You don't need to mess with XML schemas to be able to deploy virtual machines and manage them. That you can do it using PowerShell scripts. You can do it using the portal. That we wanted support for key server applications. Meaning that, and by support, I mean not just that they run well, or that they run, but they run well, and that we work with whoever makes those key server applications so that they support the application on Windows Azure. And by they supporting it, that means that when you have a problem with that server application on Windows Azure, you can call up the support for that product and get them to help you because they've made sure and validated it on Windows Azure. That we've got easy storage manageability. This is an example. If you've worked with Amazon EC2, and you know about Elastic Block Store, which is their storage subsystem for virtual machine VHDs, that it's like the Roach Motel. You can stick stuff in there, you can create VHDs there, but it's very difficult or impossible to pull them out. We wanted to make it very easy for you to go managing those VHD resources, bring them to the cloud, to on-premise, and back and forth, to be able to back them up, to be able to crack them open, to be able to mount them on different VMs. High availability features. So we know that people, when they start to get more mission critical, you'll start with dev test, but then you start to create, for example, an LOB site that might be built on SharePoint, that you might want that thing to be highly available because you've got not just your own employees depending on it, but maybe your customers depending on it. So we wanted to make sure we got basic high availability feature support out of the box. We got advanced networking, and by advanced networking I mean the ability for you to securely create VPN tunnels between your on-premises network and the cloud, because we know when you guys start moving workloads to the cloud that are for use internally or managed from inside, that you don't want to be going over the public internet to go and access those virtual machines. You don't want System Center Configuration Manager, for example, to be reaching out over the internet and back into those virtual machines, because now you've got an entry point for the bad guys to come through as well. So having secure tunneling capabilities. And then finally, again, just because we're delivering infrastructure as a service and you've seen a big emphasis on it with this set of releases that we've had, doesn't mean we've given up on platform as a service at all. In fact, we think that that's the future. That's the way that application development is going, is platform as a service, because you get these benefits of scale out and availability so easy, at such low cost. And then we had this mantra, if it requires a developer, it's not infrastructure as a service. Now this was actually, seems kind of obvious, but when you work at a company where the developers that develop products like Active Directory also work, you wouldn't believe the desire to potentially take shortcuts and go, oh, well, Active Directory needs that. Well, we can just change it. When actually we know lots of applications out there that people want to run on their cloud, people can't change. Applications that you've written, you can't necessarily change or don't want to. So we wanted to make sure that we didn't require any changes from these applications. Let's talk about the images that are available. So this is the full list, but I'm going to come back to the portal. Let's see how. All right, the virtual machine should have been created. Have I been talking for more than 3 minutes? All right. Starting. It's taking maybe it's the name, the goo. But let me come back and show you the portal experience for the gallery. And here is where you can see the full list of images that we have available for you to pick from, including, of course, #1 spot, Windows Server 2012, the best operating system, the second best operating system, Windows Server 2008 R2, and then we've got variations with SQL Server installed in them, which are also really good, BizTalk Server, SharePoint Server, Trial, so this is for your dev test, and then we got these Linux operating systems down here, if you're really into that kind of stuff. Nothing wrong with that. And you saw that I created one. And what that means when we have them in the gallery like that for you, that all of these are fully supported images. Those SQL images are supported by the SQL Server team. The SharePoint image supported by SharePoint product group. These Linux variants have been given to us by those Linux distros. The groups that create those Linux distributions have worked with us. In fact, this is, I think, one of the cool stories for me, for having worked on Windows Azure Infrastructure as a Service. How many of you know Mark Shuttleworth, know of that name? So a few of you. He was the creator of Ubuntu. He's the founder of Canonical, the company that releases Ubuntu, which is why I created Ubuntu. He just recently closed Ubuntu bug #1. Last week he closed Ubuntu bug #1 that he filed back in 2008. And that bug was Microsoft has dominant market share. Now, you know, the spirit of that bug aside, the fact that I happen to work for Microsoft, the reason he closed it is because of the shifts that we've seen with mobile and iOS and Android, and he kind of just said, well, I guess Ubuntu's part of that whole shift, Linux is part of that shift, so I'm going to just go ahead and close that bug and just say that we need to focus on making great products for our customers. But in this in the closure note, his 6 paragraphs that he wrote about that, explaining why he closed it. Paragraph number 5, by the way, if you're interested in the cloud, the guys at Microsoft and Windows Azure are technically excellent, run Ubuntu great on the cloud, and really great people to work with. And I thought that was just amazing. Closing a bug on Ubuntu, bug number 1, a mention of Windows Azure. So that was pretty cool. So that's why I gave him kind of a shout out by creating that Ubuntu image there at the beginning. Here's the full list of products that we've got supported. And you can see some of the ones that I showed you in the portal, as well as you can see down here at the bottom some of the ones that we're working on with those product groups. So Exchange and the 2 flavors of Dynamics down here are going to be coming soon. You'll see those show up as images in the gallery. I also want to highlight here the fact that we've got PowerShell scripts for just about everything. So get Azure VM image, assuming the network is going to cooperate, will return me the whole list of images that are in our platform gallery, which are even more than the list that you see displayed in the portal. The portal only picks some of them. And is it measure? So I've actually become kind of a fan of PowerShell. And don't tell Jeffrey Snover, though, because see 61 there. Every time I run into him at Microsoft, which is quite a bit, he's like, hey, have you tried PowerShell? It's awesome. And I'm like, no, Jeffrey, I'm too busy. So don't tell him that I actually kind of like it. But I can do stuff like where, $, underscore, let's see, category, oh, like. I'm working here with no wire or no net underneath me. Let's see how that goes. This will show me all the images that are SQL, have SQL in the category. So and then we can see, so you get the idea. There's like 7 or 8 SQL images in the gallery. Yeah. So a whole bunch of them. Now, those of you that have created a virtual machine in the portal might have run into something that I personally find a little confusing. It's a behavior of the portal that is aimed right at people that are just trying to kick the tires on Windows Azure. And that's, to understand what the portal's doing requires understanding the difference between a virtual machine and a cloud service. Even our marketing department has gone a little bit too far with trying to differentiate cloud service from virtual machine. So if you've been seeing our marketing stuff, it says, oh, cloud services, those are PaaS. Virtual machines, that's IaaS. But in fact, they're both really the same. And here's the explanation. When you create a PaaS application, it's called a cloud service. And what you do is you define tiers, essentially tiers, in that cloud service. Here in this, and those tiers are called roles in our application model. Here you can see a cloud service that has 2 tiers, or 2 roles, a web role, which would be the front end, and a worker role, which would be the back end. And what you can do is specify the number of VMs you want in each tier. And each tier, the VMs are stamped out with the common code and configuration. So that's why scaling is so easy. Now, they're part of a common cloud service, which means that you see them in the portal as a cloud service. For example, if I come up to the portal, and I click on the cloud services, here I can see one of my cloud services here, and you can see that I've got a few different roles. I've got worker role A, worker role B, and then a 3rd role, MVC web role. When you create a virtual machine, like I just did, or hopefully I'm finished doing, still creating. All right, so something funny is going on here. And that could be because it's Linux? No. Hopefully. Because it's the demo gods messing with me? Yes, maybe. Oh, you know what? The portal probably hasn't updated. That's probably it. So let's see if we can refresh it and see if its state is really starting or if it's really done. Well, when I created that virtual machine, what happened underneath the hood is that an implicit cloud service was made for it. That implicit cloud service, the DNS name, is the cloud service's name. And it also happens to be the name of the virtual machine, too. So there's two constructs here. There's the virtual machine name and the cloud service name. And the GUI, yeah, so it was, it's retrieving status still. So, yeah, it's been running for a while. So that was a portal just having network issues. So that's been running for a while. But what's been created under this is an implicit cloud service. And if I do get, well, so it's called the GUI, the DNS name. But if I go to cloud services, I won't see the GUI as a cloud service. And if I do get Azure service, this will show me the list of Azure services that I've got in subscription. And, let me just make sure I got the right subscription here. Mr. Azure, set. Whoops. Set Azure subscription. Sub. And where's the GUI? Oh, sorry. Get Azure VM. Service name. See, I tell you, I'm not a super expert at PowerShell yet, but I'm getting there. So if I do get Azure VM, this will return me the full list of VMs I've got in the cloud service. Yeah, PowerShell, turn on the light. Maybe I'm better at it than I thought. And why am I not seeing this? Is this really Mr. Azure Mark our demo? Oh, it's not Mr. Azure. It didn't set the, it's select Azure subscription. Mr. Azure. That's the problem. All right, now we can do this. Get Azure service. And then, there we go. All right. Whew. The GUI. And actually, if you look, it says description, implicitly created hosted service. So that is what the portal is using as a filter, so that's why you're not going to see it show up in the portal when it's really there as a service with the VM inside of it, also called the GUI. Why am I going into all of this? Because in the portal, when you go and add another VM to an existing VM, and I'll show you in a second how to do that, but let me first highlight the fact that I've got this VM right here, Server 2012, 16 terabytes. Its cloud service name would be IaaS16TB, but I created it as a standalone. Actually, why don't we just do the GUI? Let's add to the GUI. New virtual machine, quick create, from gallery, and I'm going to create another Ubuntu, and we'll call this the GUI 1. And I'll press provide password. It looks like networking is going a little better. And then here I get asked, do I want to create a standalone, which is what the quick create does, or do I want to connect to an existing virtual machine? If I select this, then I get to choose from any of the other virtual machines, which is what that is doing is going to put the virtual machine I'm creating into the same cloud service that the selected virtual machine is in. Now, the GUI is in that implicit cloud service. When I select this and press next, I get asked one more question, which is about availability sets, which I'll talk about later, and I press OK. We'll come back in a few minutes and see how the portal at this point will show us now the GUI as a cloud service. It'll get promoted because it can't hide it anymore since there's more than one virtual machine that is now part of that cloud service. So the portal, what it's doing is trying to make it so that it's not confusing to people that are just creating a virtual machine. They don't have to know what a cloud service is, which is really just a container. And as part of that container, you get this management ability, so you can shut down or delete the entire cloud service. It also has networking security that's built into it, which I'll come to a little bit later when I talk about networking. Let's talk about the disks now underneath these things. So there's two types. I don't think that's me. It becomes what's called a disk. And a disk is really a specialized VHD. Specialized meaning that it represents an actual VM or data that's stored on it. And you can create these specialized host VHDs, OS VHDs, like we've been creating. You can also create data VHDs. And you can attach data VHDs to your VMs. In fact, you can attach a number of them to these VMs. All right. Yeah, things are going smoothly this morning. So you can see that the number of VMs that you can create varies from 1 for an extra small virtual machine up to 16 disks that you can create on an extra large VM. Now 16 up to 1 terabytes in size disks. So you can see that all of these attributes across these VM sizes scale. By the way, the A6 and A7, there are new VMs that we just released also at the time that we did GA back in April. So these are the high memory, essentially, VMs. You can see they're weighted more towards RAM than CPUs than the other VMs. As far as performance, our target is 500 IOPS per disk of small IOPS, 32K, 8 to 32K kind of IOPS is getting 500, whereas a typical SATA storage disk will get somewhere in the neighborhood of 100 or so IOPS of those sizes. One of the things that I do for this demo is create a VM with lots of disks on it. It's an extra large, and this is the PowerShell command that I came up with to go and create that VM and attach those disks to it. So you can see add Azure Data Disk, add Azure Data Disk, add Azure Data Disk, and it's going to be creating these as 1 terabyte in size. By the way, the portal thinks that 1 terabyte is 1,023 megabytes. The portal guys, you know, they're great guys, but I don't know if they had computer science classes. So what I'm going to do is, that is that VM right here that I've got, this server 16 terabytes. If I scroll down here, you can see that it's got the OS disk and a bunch of data disks. Now, the script only creates 15 because I wanted to save attaching a disk for you as part of the demo. And I can attach an existing disk. So if I had a disk laying around that, for example, had some data on it and I wanted to attach it to this, to mount it on this, I could do that. I'm going to create an empty one. And here I'm going to create 1,023, 1 terabyte. And you can see that I can set the host cache preference here. None is the default. Read only and read write are two other options. And I'll describe those in a minute. I'm going to say none. And while that's creating, let's go and RDP into that VM to see that disk show up. And I'll show you one of the things that I can do with it. When people talk about performance or size, there's two reasons that you want to attach multiple 1 terabyte disks. One is size because what you could do is stripe them and get up to a 16 terabyte volume, which is what I'm going to demonstrate for you. But the other reason to stripe them is obviously performance. If you've got an application that can take advantage of the parallelism of getting the 500 IOPS off each disk, then you can get 500 times 16, whatever that number is, IOPS. I think it's 8,000. IOPS off of one virtual machine in Windows Azure. There's a great session that's coming up on Thursday morning, which is on SQL Server management on Windows Azure Infrastructure as a Services, which includes discussion of SQL Server performance. One of the mistakes that people sometimes make is that they create a stripe using Windows striping and then put the SQL Server database on that. But SQL Server knows how to split the database across individual disks or JBOD set of disks, so there's no reason to do that. In fact, you shouldn't do that because SQL Server will get better performance if you just let it hit those disks individually. So we're logging in here. I just created this virtual machine, which is why you see the first login here. I created the virtual machine this morning just by running the PowerShell script. I've got another script that will tear it all down and then so I can relaunch it for another demo. And let me pull up disk management. And what you're going to see is a whole bunch of disks here, and that 16th disk is probably shut up by now. Yep, there's 2 to 17. So I'm going to go ahead and initialize them. And after they're initialized, I'll just quickly make a stripe out of them. Okay, it's almost done. And now I can say new stripe volume, just like you would normally do for on-premise. I can say add, next, next. And you want to make sure that you check this. There's 2 reasons why. One is that, obviously, it'll take a very long time. But the other one is that Azure is a sparse storage subsystem, and you only pay for what you use. So when you write a block to a volume, then that becomes a block that's a concrete block in Windows Azure Storage. The ones you don't write to in a blob won't end up costing you anything. In fact, we are imminently going to release trim support. We don't have it in there right now, but trim support so that when you delete files off of your volumes, that you'll also get those blocks will get cleaned up on the back end. And I'm kind of getting ahead of myself because I'm talking about how we implement the storage, which is the next topic. Because underneath these VMs, we're using Windows Azure Storage, blobs. If you've used Windows Azure before, as PAS, you know that we've got tables, Windows Azure Queues, and Windows Azure blobs. And blobs are what your PAS would stick video files and images and binaries, even packages that you would pull into your virtual machines. What we decided to do when we set out to design infrastructure service is not to create a second storage subsystem, but rather make Windows Azure Storage great at serving block storage using the blob technology that's already there. Few reasons we decided to do that. One, we didn't want to go reinventing everything twice. Wherever we wanted security, whether we wanted management, REST APIs, if we had 2 separate storage systems, we'd have to do it twice. Security improvements, scalability improvements, twice. The second is that by having one, that means that all you have to learn are one set of APIs, that tooling only has to be written once to be able to manipulate these things. And we also get this, like here's an example of what we get out of leveraging Windows Azure Storage is the durability. When you write to a blob, it gets triplicated on the back end to 3 different servers. So this can tolerate multiple failures without you losing data. And there's asynchronous geo-replication as well that occurs. And to demonstrate just how cool it is that we can leverage the same tooling, here's an application called Cloud Explorer, which is used to manage Windows Azure blobs. And I'm pointing it at the storage account where I created those VHDs, and it just sees them as Windows Azure blobs. I can use everything about this tooling on those blobs, even though they're actual VHD disks underneath them. I can even copy them. How long does it take to copy 1 terabyte, by the way? That's a one. Oh, here's a 1 terabyte one. Actually, here's the 1 terabyte disks. So how long does it take to copy? Well, let's copy that to here. Actually, let's make a new container. New container, copy. And how long do you think it'll take? I'm going to press Control V. 5 minutes. Done. There it is, 1 terabyte right there. Unbelievable. Quantum technology. That's what that is. No, I'm just going to. No, that's just, what that is copy on write technology. So that's what we do if you copy within the same storage account is just copy on write. So you can create snapshots of disks using the same technology, copy on write. It's free. In fact, I'm not paying anything more for that copy than I am for that original blob. Unless I go and now modify this thing, then I'll pay for the differences. But they're both sharing the same underlying storage. Let's talk about high availability features now. So the SLA that we started out with very early when we released Windows Azure was a 99.95% SLA for multiple role instances. I believe that we've updated it recently to a trailing month. So 43 minutes, basically, we get of downtime a month. And what's included in that is everything that's our responsibility. So the data center hardware, for example, the network, the servers, the disks, all our responsibilities. Even planned outages, because we go and update the host operating systems. The root OS is underneath all our servers. They're running Windows Server Hyper-V, and we patch them and we roll out security fixes and reliability improvements about once a month. We count that as our responsibility as part of that SLA that we've got with you. What's not included, of course, are things that are your responsibility. So whatever you stick inside your VMs, that's your call. You can put in crap in there that just doesn't work or crashes your VMs. We can't do much about that. But everything else is covered by our SLA. How does IaaS relate to SLA? We don't have a single instance SLA, an explicit SLA on single instance today. We've got an implied one because when you've got two VMs with that together have a 99.95, you can do your statistics and figure out that there's a 99.76% SLA effectively on each single instance. But together, that's what we've got as a business contract with you is two of them. And so how do you get high availability, and how do you opt into this SLA on Windows Azure with virtual machines, with IaaS virtual machines? What you need to do is to deploy a high availability solution into those VMs and put them into what we call an availability set. An availability set makes it so that the platform places these VMs such that they both don't go down, or very unlikely that they'll both fail in the case of a server failure, a disk failure, a rack failure. And that when we update the host operating systems underneath them, that we'll only do one at a time. So we'll make sure that they're on different servers, and that when we update the host OS on one server, we're not taking down both VMs. And then that's what's called an update domain. Let me show you an example application that I've got where I've put it in. By the way, here's my 16 terabyte stripe, which has been made here. And if I click on properties, you'll see it's a nice big disk. There, 16 terabytes. But going back to the portal, I've got this application here. It's a cloud service because I've got multiple VMs in it. And if I go to instances, you can see that I've got two instances in here, two web front ends. Now, these web front ends are connected to back-end SQL servers. They're also domain joined, which I'm going to show you in a little bit. But these front ends, I wanted to be highly available. This is running a line of business application. And so what I've done is I've put them in an availability set. If I go to one of these and I say configure, you can see that I've put them in the web AV set, the web availability set, and that both of those VMs are a part of that same availability set. So what effect does that have? What is this update and fault domain concept? Let's talk about, by the way, this is a picture that, animation that a friend of mine made, and he thought it was so awesome that I put it in. And it talks about here, or really visualizes, the single points of failure we have in the data centers. You can see that physical machine is one, the power unit switch, which is there on the left, is another one, and then, whoops, then you can see he's got, look at that, ooh. So there's 3 racks, and if we have 2 VMs and we put them in an availability set, you can see that they're placed in 2 different racks, not just 2 different servers. And that is because the rack itself is a single point of failure. The top of rack router and the power PDU that manages that rack, the power on that rack, can both fail, and we don't want both those VMs to go down. So these different racks are called fault domains. And when you create an availability set, put the VMs in them, they'll be spread across at least 2 fault domains. They'll also be spread across at least 2 availability update domains. But let's go back and look at these VMs here. And when I click on instances, you can see the portal will show us which update domain and which fault domain each one is in. So they're in 2 different racks, as demonstrated by being in 2 different fault domains. And they're in 2 different update domains, meaning that when we update the host operating system underneath these servers, that one will go down. Once it's back up and running, then we will be able to update the host OS on the other server. And that's the way that you get high availability. Yes, question was, in addition to that, we also have geo-redundancy. The geo-redundancy doesn't apply to the compute, it applies to the storage. So I mentioned that we have 3 copies of the data of the blob in a data center. We're also asynchronously replicating to another pairwise data center. It's an asynchronous replication, so if there was a total data center disaster, there would be some loss of data. The copy lags by about 5 to 10, 15 minutes. We don't have an SLA on that at this point, but that is something that we've got implemented on Windows Azure Storage in case something horrible like that happened. Here's a graphic, another way of looking at the way that we will spread these VMs across fault domains and update domains. This is showing you how a PaaS application would get spread, because PaaS applications basically have implicit availability sets. A role is an availability set. So the instances of the role here you can see got spread across fault domains and got spread across update domains. When it comes to VMs, you need to be explicit about it because they're kind of standalone. So you need to say, hey, these are really kind of a role, so they should be laid out in that same kind of way. Now let's talk about Windows Azure networking and the networking features we've got, because I mentioned that it's not just about the virtual machines. Now we've got these virtual machines up and running, but they need to connect with each other. They also need to be able to connect to the internet. We might want load balancing, for example. And then finally, we also potentially want to have a secure tunnel, like I mentioned, back to on-premise or CorpNet. When we started out with infrastructure, or platform as a service, rather, we had just platform as a service type networking features, which means that we didn't support things like DNS. Like I mentioned, you had to use a runtime API to query the names of the virtual machines, to query the IP addresses of the virtual machines. So part of this release, big release, was a Windows Azure provided DNS service for those virtual machines, so that when they boot up, Those VM names you give them in the portal or PowerShell, they get registered with DNS, and so another server can look them up. That's part of the same cloud service. The DNS scope for Azure DNS today is a cloud service. Then there's also bring your own DNS. So we made it possible for you to bring your own DNS servers and add them so that you could, for example, stick a DNS server in the cloud and then have it, if you made that accessible for multiple cloud services, then VMs in different cloud services can register their names with that DNS server and then find each other. Or you could point at an on-premise DNS server. For the case where you're creating a secure tunnel now, those VMs in the cloud can find your VMs on-premise and vice versa by pointing them at an on-premise DNS server. I'm going to show you some examples of all of those things. When we started out with Platform as a Service, we also didn't support things like UDP, only TCP traffic. So we added UDP support. Lots of server applications like to talk UDP. It also turns out that media streaming over the internet likes UDP, so this benefits both PaaS and IaaS because we got media services PaaS support. And then we supported ICMP and dynamic ports as well, something that we didn't support either. With Platform as a Service, you had to go and model the endpoints that you want open between your VMs or your roles in a cloud service. Here, you can just, like I said, open the firewall port, and then those VMs will be able to see each other. We also have port-forwarded endpoints, which is something I'm going to talk about, which is the ability to take a public IP address and have certain ports on that public IP address mapped to certain ports on specific virtual machines. And then finally, load balancers support for virtual machines, including the support for custom load balancer health probes. So let's talk a little bit about these. First, with port-forwarded input endpoints. When you create a cloud service, today you get one IP address, public IP address for that cloud service. This is something we're working on expanding in the future, so you'll be able to bring multiple IP addresses and associate them with the cloud service. But today, you get one publicly routable IPv4 address. So we had a challenge to address when we realized, people want to connect to specific virtual machines. With Platform as a Service, what we do is we stick an agent inside of each virtual machine, and that agent forwards traffic to the target destination RDP. It's called an RDP forwarder. We can't put agents inside these virtual machines. In fact, our virtual machines work without any agent in them. This is in contrast to other platforms where you need to stick an agent in there. You can bring a Hyper-V VM on-premise, and assuming that it works with the virtualized hardware we have out in the cloud and you connect it to the network, it will work right out of the box. So that's part of the mobility of virtual machines back and forth. And that means that we didn't want to require an agent, so we couldn't rely on RDP forwarding. Instead, we take this approach, which is to map certain public ports to the private ports on the VMs. Let me show you an example of that. That Fabricam Cloud Apps right here, this thing, if I go to look at the endpoints on a particular one of these, you can see that there's 3 endpoints that are mapped onto this, and I can create these endpoints in the portal or through PowerShell scripts. So for creating the endpoints, the public endpoints, the ones that are visible, they're mapped to the public IP address of the cloud service, I need to use the PowerShell or the portal. I can't just open the firewall port because our load balancer needs to know about it. But you can see that I've got RDP, a web, and web deploy server 1. I made these names. You can see that the protocol is TCP, or it could be UDP here if I wanted. And then there's public port and private port. This is where port forwarding is visible. For RDP, we want each VM to be uniquely addressable. So what you'll see is that there's a public port, 55.182, that maps to private port 3389, which is the standard RDP port on those VMs. And you can see that it's not load balanced, which means it's port forwarded or port mapped 1-to-1. The same thing for this web deploy, so I can do web deploys into it. Public port 50,001 maps to 8172. But for this web port, it's load balanced. So there's a direct mapping on the way through, just because that's the way the web application wants. When I do a connect, if I go to Web Apps Manager 1, and it looks like the network might, here we go. Web Apps Manager 1, and I say connect, what this will do is open up an RDP file or download an RDP file that already has that port forwarded endpoint in it as configured. So it will take me to the right one. So if I say foobar1, password 123, then what I'll see, hopefully in a second, is, oh, there it is, 55.182, which is actually what I showed you. That is that port, and that is mapping to RDP there on that VM. Let me come back to that in a second. I wanted to show you, by the way, the fact that that DNS, how that works and with cloud services. And I've got those two Linux VMs that I added. Remember way back when, the GUI? And now that we've got this cloud service that popped up, just like I said, the portal's now showing us the cloud service. And if I click on this, you'll see that there's two instances, the GUI and the GUI1. And the first instance, it nicely maps to port 22. So the port forwarded endpoint for that is going to be the standard SSH port. And if I open that up, Azure user, let me go back to the other one, the GUI1, and do the same thing. And what I'm going to do is show you that these guys can see each other. And this one is the GUI, but at this port, see how that other one's doing? Here it is. Oh, yeah, usernames. I forget Unix, even the usernames are case sensitive. So let's try that again. Where was that? I'm lost. Up, here it is. If this was a sysinternals tool, it would just remember all that. And, okay, we're going to log in eventually. And these will now be able to talk to each other over their IP addresses and their internal IP addresses. Because every VM gets an internal IP address as well as this public one. The public one is mapped to that DNS name. But you can see that here's an internal IP address. And this is the GUI1 internal IP address, which is 168.170.64. I'm on the GUI2 here. Oops. I didn't mean to do that. Ping. And you can see that it's able to ping that other VM because it is part of that same cloud service. If I ping the VM from a different cloud service, it's going to time out because that's part of that network security boundary that I mentioned that's part of the cloud service abstraction. I also wanted load balance, like I mentioned, and you saw that port 80 was a load balanced endpoint there on that front end. That load balanced endpoint is created using a load balance set. And the way that we create a load balance set is, again, through PowerShell scripts or through the portal. What you'll do is create an input endpoint and make it part of an input load balance set, and then add VMs to that load balance set. When I go back to that cloud service with that front end, you can see that I've got here Fabricam Cloud Apps. Here's the DNS address. What this will do is tell me after I log in which of the front ends picked up the request. And it'll be either Web Apps Manager 1 or Web Apps Manager 2, depending on which way the load balancer redirected me. I've got another example application which really highlights, in this case it was Web Apps Manager 1. I've got another example which really highlights this load balancing concept. Here's a cloud service that has a whole bunch of instances. It's got 6 instances, and these are all load balanced. If I go back to the dashboard and I click on this, each VM is going to uniquely display a background which tells it which one it hits. And I'm pressing F5, F5, F5. The way that the load balancer works, it's working off a 5-tuple: source port, source IP address, destination port, destination IP address, and protocol. And as long as that set of 5-tuple remains constant, there's consistent hashing, which means I'm going to always get to the same front end. So what IE is doing underneath here is the source port is dynamic. So that's going to be changing, and based on the hash across those VMs, I end up on a different VM every time I press F5, going through that load balancer. This is also, by the way, if you go back and we go back and take a look at this application here, I've also got port forwarding turned on these things, so I can hit the endpoints, hit them directly. So you can see I've got this HTTP, which is what we've just been looking at, port 80, which is load balanced here. But I've also got port 80, the private port 80, mapped to this public port, 30,000. Input endpoint I call direct to HTTP, which is not load balanced. It's port forwarded. That means that if I go back here and hit port 30,001, that's going to be hitting VM1. And there we go. So that's port forwarding in combination. The load balancer works within a data center, within a cloud service today. And so this is the rest of that animation, which shows you load balance sets. And the load balancer is spreading now across the 2 front ends. And that's where you get the 99.95 SLA. Another feature we added is the ability to set custom load balancer probes. So by default, what the load balancer is doing a get on the root of just on the port there and just saying get. And if it gets back an OK, it assumes that the VM is healthy. If not, if it misses timeouts, by default it does probes every 15 seconds. If it misses 2, it'll take the VM out of rotation. But you can specify custom load balancer probes path. So you could say, for example, I got a special health code that checks the health of this thing, and it's going to respond on a certain URL there, certain virtual directory there, healthcheck.aspx, implement the custom logic, and then respond either with an OK or not to the load balancer. And that way you can control how these things come into and out of rotation. You also now, as part of the release we made yesterday, can specify custom load balancer probe intervals and timeouts. So the default is 15 seconds for the interval, 31 seconds for the timeout, but you can set those down to granularities of 5 seconds, I believe. Now, final topic is cross-premise connectivity. Well, actually, final topic before I just wrap up with a segue back into how this fits into PaaS and how we see these things blending. And that is the ability to do the secure tunneling or secure connections between different networks. We have a feature that we previewed just a few weeks ago, secure point-to-site network connectivity with virtual networks. What this allows you to do is create a virtual VPN point-to-site gateway. This is great for dev test. So what you'll do is go to the portal and create a point-to-site virtual network, and then create a VPN endpoint on your local dev box, upload a certificate to the cloud, and then you'll get a tunnel from your local machine up into the cloud. And that is a great way for testers, people doing dev test, to be able to get a secure tunnel up into their cloud or into their cloud service with their virtual machine so they can deploy code to it, test databases on it from their on-premise without having to expose that thing on the internet. That, though, for IT scenarios where you've got corporate networks and you want your corporate network basically to extend up into the cloud, you're going to want to use the secure site-to-site network connectivity, which is what I'm going to be focusing on right here. In the site-to-site connectivity, both the point-to-site and site-to-site leverage this feature called virtual network. What a virtual network is an overlay. An overlay of subnets that you can place on top of your cloud services. It allows you to overlay cloud services with your own IP addresses that will be compatible with your on-premise IP address space, because ours might not be, the default one that you get in the cloud service. And you can overlay the subnets across multiple cloud services. So you can have multiple cloud services that are joined inside the same virtual network, giving them each subnet ranges to get IP addresses from that are non-overlapping. And so basically a way to carve up an IP address space across cloud services or VMs and cloud services. That's one use of it, which is to be able to connect multiple cloud services in a secure way, which you can't otherwise. You see that when I did that ping between two VMs in the same cloud service, I was able to because they're part of the same network security boundary. But I can't ping across cloud services unless I put them in a virtual network. And this application that I've got, this Fabricam thing, is part of a virtual network. When I go back to Web Apps Manager 1 and I go to Configure, I see that it's part of the AppNet virtual network, and it's part of the front-end subnet. The Web Apps Manager 2 is also. And the reason that I've put this in a virtual network is that this thing is talking to SQL servers and is domain joined as well. The cloud service that contains the SQL servers and is domain joined is right here, Fabricam DC1. And if I go to instances, you can see that I've got two domain controllers here up in the cloud with SQL Server Always On Mirror in the cloud as well. And these are part of different subnets of the same virtual network. You can see the DNS subnet here. And when I go back to here, what this allows me to do is have this secure connection between my front ends, which are sitting on the open internet, and my DNS server, my Active Directory server, and my SQL servers, which are sitting here in separate cloud services with no exposed endpoints to the public internet. And that's why I want to note that DNS does not span cloud services today. It will in the future. But today, Windows Azure DNS only is within one endpoint, within one cloud service, which is why I've got a DNS server there as well, so that the Web Apps Manager can find the SQL servers and the Active Directory domain controller. But let's take it a step further. Now let's create a gateway, or show you a gateway, that connects the cloud, those two cloud services that are part of that virtual network back to my on-premise network, where I've got another domain controller that's part of the same forest sitting there. So this is what you'd want to do for performance, is put a separate site up in the cloud. That way that the VMs in the cloud are talking to those DCs up there instead of coming back in through the tunnel to your on-premise domain controller, which is this scenario that I've got right here. If I go to the virtual network configuration page, you can see here's app VNet. And I've created a gateway, the app VNet gateway, which is connected to my CorpNet on-premise network. And when you create a public gateway, you see that you get a gateway IP address here, which is what you'd want to configure for your VPN device. Let's go into that VPN device, by the way. And I can get to it all the way from those front ends. That one that I remoted into here, by remoting to the DNS address, if I go to configure, I know that the on-premise DNS server, where is it? On-premise DNS server, 192.168.1.6. So I'm going to RDP from the front end into that, which also happens to be the on-premise Active Directory domain controller. See, I'm logging in as Fabricam administrator. And it also happens to be where the VPN device, with the server that the VPN device is connected to. And what we'll be able to do is just take a quick look at that VPN device configuration and see that it's pointing at the Azure gateway to be able to talk up into the cloud. You can see here I've got Active Directory users and computers open, and you can see all the machines. In fact, I've got more machines. There's the SQL servers sitting up here in the cloud. Here are the domain controllers, DC1 and DC2. I happen to be on DC1. And or sorry, those are the cloud domain controllers. I happen to be on the on-premise domain controller, and here I'm connecting to the Cisco VPN device manager, which I'll be able to look at the configuration of the VPN device and see that it is pointing at, if I go to configure, and so this is actually going up into Azure, back through the virtual gateway, back into Microsoft's network, actually, on campus, into a guy's office, to a machine that's under his desk. So this is actually sitting there, and I hope nobody kicks it when they go by. And if I go to configure and I go to remote access VPN, or actually site VPN is what I meant, then you can see here, there's the 137.116.208.67, which is what we were looking up at in the portal. And that is the connection. So that is an example of getting that tunnel all the way back to on-premise. So final few minutes here, I just wanted to circle back and talk about IaaS and PaaS and the way that we imagine the world shifting. People are going to be, literally, the term we use is lift and shift. Taking your workloads, first your dev test scenario workloads, bringing them up into the cloud, over time gaining confidence with the cloud, understanding the way to manage the cloud, and then starting to build tier 2, tier 3, tier 2 applications up in the cloud. And over time, at your pace, you'll decide to onboard into PaaS. This might be new applications that you decide to build in PaaS, or take existing applications and upgrade them to PaaS. That application that I showed you is a fully IaaS application. It's web front end and SQL backend in VMs. That's a great application, actually, to PaaSify over time. Those front ends are stateless front ends. There's no reason to have them be IaaS virtual machines. We can have them be web roles. And so what you can do is today connect your web roles and your worker roles in a few different ways, your web roles and your VMs in a few different ways. One is through VIPs. Another one is to put them in the same VNet. Another one is to domain join, to connect them to a domain joined system. So you can actually domain join your web roles or worker roles as well. Let me show you very quickly, that's the last thing, that I've got two other versions of this application. Here, Fabricam Cloud Service here, which has two instances in it. And you can see they've got different names. They're assigned by the platform. These are the same application that we just saw, except running in web roles. And they're part of the same VNet. If I go to the dashboard and I connect here, you'll see the interface looks exactly the same because it's exactly the same code. And you'll see the exact same, okay. Oh, I know, Fabricam. Maybe. Wait, okay. Looks like something happened here with my demo. But what you should have seen is the exact same list of events because it's supposed to be talking to the same SQL Server database because it's part of the same virtual network. And then over time, you might want to get rid of those SQL servers and make it fully SQL Azure enabled, which is the final big step, which is just having the whole thing be pure PaaS, which is this slide right here. And you can still domain join them and put them in VNets and have them talk to on-premise, as shown here. And I've got the third application. I'm afraid to show it to you now because all right, you want me to try? All right, I'll try it. Hopefully go out on a high note here. This one is the full PaaS one and the same UX. And let's see if this one is able to talk to the SQL database. And, okay. All right, well, I apologize for that. It was working earlier this morning. But I guess just par for the course, we haven't had a demo failure in about 30 minutes. So, so with that, I want to just conclude with by reviewing these set of principles that we started out with. I think we hit them. You can create some really cool scenarios pretty quickly and easily using the capabilities we've developed and released. And here's some related sessions that are, wow. So, yeah, it's amazing that I got through the presentation at all. And I want to thank you very much. I've got another session. If you're interested in a deep dive, behind the scenes look at the way we operate Windows Azure and the way that it's architected, come to my session tomorrow afternoon. And then, like I said, these related sessions all go into how to develop IaaS applications on Azure. Thanks very much for coming. Hope you got a great TechEd.